Greeting everybody. I hope you are having a good day. My name is Nirmit R. Saliam, Math Lecturer, Shakthi PU College, Shakthi Nagara. Today, I am here to discuss few topics about the 5th chapter of First PUC Mathematics, that is complex numbers and quadratic equations. I'll be telling you the brief about the chapter, what to study, what will be coming in the exams, what is the weightage of the lesson in your exams. In the chapter complex numbers, now first you have to study what is a complex number. We have studied what is a real number in our 10th standard. We know the real numbers, we have said that it is the number that exists, or the numbers that are real are called as real number. Now there are numbers that are not real also. The hint that was given to you in your 10th standard was about when you were finding the roots of the quadratic equation. You were said the discriminant value b square minus 4ac, if this was greater than 0, the roots were real and distinct. If it was equal to 0, it was said the roots are real and equal. But if this value b square minus 4ac, the discriminant, was less than 0, it was told to you that the roots are imaginary. Now such kind of numbers we are studying, then the topic called as complex numbers. We might term it as an imaginary number also, but specifically saying complex number is a number that can be written in the form of a plus ib. We usually denote this complex number by a small letter z. Here in a plus ib, we know the a value, whatever we are having, is called as the real part. And the value b is called as the imaginary part. Now, what is this I? That is a very important thing. I is nothing but it is equal to root of negative 1. Why are we considering root of negative 1 as I is? We have the roots of the positive values. You know, the root of 4 is plus or minus 2. But when it is given a root of minus 4, we have to check what is the value. Actually, root of 4 in the sense when I square 2 or minus 2, I am getting the value 4. So we are saying the root of 4 is plus or minus 2. But if I square anything, I will not get minus 4. So we have considered this root of minus 4 as root of 4 multiplied to root of minus 1. Hence, we are writing this root of minus 1 as I, so that we'll be able to write the value as root of 4 into I. Now root of 4 into I can say it is plus or minus 2i. This is called as an imaginary number. The value that will be having I with that is called as an imaginary number. Usually I is taken from the word iota. Now here we are denoting the I as root of minus 1. Vice versa, the value of root of minus 1, we are writing it as I. Now once again, to say what is a complex number, a number that can be written in the form of a plus ib, where a and b are the real numbers and I is equal to root of minus 1. I told you what is a complex number. There is a definition given. I told you we are writing it as z is equal to a plus ib, where a and b are the real numbers and I is equal to root of minus 1. Here once again I am telling you a is called as the real part. That real part is denoted as re of z. Z denotes the denotion of the real number. So the same way b is represented as imaginary part and it is given as img of z. There are few examples for the complex numbers given. The first one is z is equal to 2 plus 3i. If I say in the 2 plus 3i, I'll say 2 is the real part and 3 is the imaginary part. There will be a confusion when there is a real part and imaginary part asked. Everybody will say the real part is 2, but when the imaginary part is asked, you will say it is 3i. No, it is not 3i. It is just 3. 3 is the imaginary part. The same way, real part in the second example is root 7. The imaginary part is minus 1. It is not minus I, it is minus 1. The same way in the third one, as you can see, the complex number is given as z is equal to 4 plus 0i. 4 is the real part and the imaginary part is 0. I can just write it as 4 also. It says you the real part can also be a complex number, which describes us the real part is a subset of the complex number. The real numbers are the subset of the complex numbers. The same way here, one more thing to say, if I'm having 4 plus 0i, I can say the imaginary part is 0. There is no imaginary part. Such kind of numbers are called as purely real because they don't have any imaginary part. Coming to the next example, as you see, z is equal to 0 minus 2i. Here, the real part is 0. The imaginary part, if I ask, it is minus 2. Such kind of number where the real part is 0 is called as purely imaginary. The two things to learn: there will be a real part and an imaginary part, and also there are the part called as the number called complex number called as an purely imaginary as well as purely real. When I say purely real, the imaginary part is 0. When I say purely imaginary, the real part is 0. Just to keep with an examples here, the examples might be of any kind. A and B are real numbers, I said. They might be a root number, they might be a fraction, they might be decimal as well. We are just representing every complex number in a possible way of a plus ib, where the first will have a real part as well as the imaginary part. Next, going for the powers of I. I told you what is I. I is root of minus 1, I told you. The powers of I, we'll see what happens if you are having I square, I cube, I power 4 and all. Now, we know that I square, I is root of minus 1. I square, I can say it is root of minus 1 the whole square, which is nothing but equal to root of minus 1 the whole square, which is nothing but minus 1. So I square is minus 1. You have to keep in mind always, because it is a very important topic. If I have to multiply the terms, the multiplication of complex number in any way, if I get I into I, that will be I square. The value of I square is always minus 1. Similarly, if I have to get the value of I cube can be written as I square multiplied to I. Now we know both the values. I square is minus 1 into I. I can say it is minus I. The value of I power 3, that is I cube, is minus I. The same way, if I ask you I to the power of 4, I to the power of 4 can be expanded as I square into I square as of our knowledge. I square into I square is nothing but I square into I square will be nothing but minus 1 into minus 1, that is equal to positive 1. These are the four main values that I have to keep in mind. One is I is equal to root of minus 1, I square is equal to minus 1, I cube is equal to minus I, and I power 4 is equal to 1. I'll tell you why. Because if I have to expand something like I to the power of 26. Now you know I to the power of 4 is 1, the very expanded value. I power 4 is 1. I to the power 26, I can write it as I to the power 24 into I to the power 2. I'll tell you why. Because I to the power 4 is 1, I know I power 8 will also be 1. Because I power 8 can be expanded as I power 4 into I power 4. That will be 1. I power 4, if I power 4 is 1, I power 12 is 1, I power 20 is 1, I power 16 is 1, I power 24 will also be 1. So we are expanding to the nearest power of 4. I power 26, I'll write it as I power 24 into I power 2. Now I power 24 will obviously be equal to 1. Multiply to I power 2 is minus 1. So 1 into minus 1 is minus 1. Any powers of I can be found out if I know these four values. That is I square, I cube as well as I power 4. Once again I am telling you, I is nothing but root of minus 1. I square is minus 1. I cube is minus I, and I to the power of 4 is 1. I to the power 30, if it is asked, you are going for the nearest multiple of 4 among 30, that is I to the power 28. Into I power 2 I can write, that will be I power 28 is 1. 1 into I power 2 is minus 1, that will be minus 1. I hope you have got this thing. We'll just go for the next topic. Next, coming to the algebra of complex numbers, to add and subtract, multiply and divide complex numbers. What are we supposed to do? How are we supposed to do? So for that, we'll consider two examples for the complex number in general. I'll say the first complex number I'll write as Z1 given by A plus IB, and one more complex number given as Z2 given by C plus ID. Now if I have to add the two complex number, the addition of Z1 and Z2 is represented as Z1 plus Z2, and it is given by. How are we adding? To add the two complex numbers, the real part of the first complex number is added with the real part of the second complex number. The same way imaginary part is added with the imaginary part. It is similar to our algebra. In our algebra, how do we add the like terms? The same way, A is a real part of the first number, C is the real part of the second number. So you are writing A plus C plus the imaginary parts. I'll have IB plus ID, where I can write it as I multiplied to B plus D. This is for the addition part. Suppose if I have given you 2 plus 3I should be added with 5 minus 4I. My addition will be real part with the real part, that is 2 plus 5. The real part is 2 and 5. 2 plus 5 is 7. The imaginary part is 3I plus of minus 4I. 3I minus 4I is minus I. This is you add the two complex numbers. The subtraction goes in the same way. If I have to subtract the two complex numbers, the same Z1 and Z2. Z1 minus Z2 will be equal to the real part minus the real part of the second number. That is A minus C plus I into B minus D. If I have to write it separately for you, Z1 minus Z2 will be equal to A minus C, that is the real part, subtracted with the real part, added with I multiply 2. This imaginary part minus the imaginary part will be B minus D. This is the subtraction what we are having. The example, if I have to give the same way as of our addition, 4 plus 3I should be subtracted with 3 plus 4I, if I have to say. Our subtraction will be easy. That will be 4 minus 3. 4 minus 3 is 1. 3I minus of 4I. 3I minus 4I will be minus I, is our subtraction. It is like the addition and subtraction is a real part is added with the real part, and the imaginary part is added or subtracted with the imaginary part itself. Very importantly, going for the multiplication part. If I have to multiply the two complex numbers Z1 into Z2, it is similar to multiplying the two binomials, that is A plus IB should be multiplied with C plus ID. Here, the multiplication goes like, you know how to multiply. It will be A into C plus A into ID. I can write IAD plus IB into C, that is IBC, plus IB into ID, that is I square BD. Here, I told you, wherever you are getting the value of I square, you know the value of I square. The value of I square is minus 1. So I'm replacing that I square by minus 1. I'll have AC. Now when this is I square is minus 1, it becomes minus 1 into BD. Will be a real part. I'll say it is minus BD. Then the two things that are remaining is an imaginary part where I is common, multiplied to AD plus BC. So this is the multiplication of the two complex numbers Z1 and Z2, that is AC minus BD plus I into AD plus BC, for the general form of A plus IB and C plus ID. With the numbers, it is easy for us to multiply, subtract, get the answers or add the things. Next, going for the division part. The division of two complex numbers, I'll write it as Z1 divided by Z2. Z1 by Z2 can be denoted as A plus IB, that is Z1, upon the second complex number, that is Z2C plus ID. Now, how do you divide this? We have been very familiar with the method of rationalizing the denominator from our high school. The same thing we are doing. Usually, we don't keep our complex number in the fraction form. We always tend to write in the form of A plus IB at last. So, to simplify this term, I have to rationalize the denominator. Denominator being C plus ID, I have to multiply by the rationalizing factor, I would say, that is c minus id for both numerator as well as the denominator. As you simplify by multiplying c minus id for both numerator and denominator with the multiplication process, I'll have a complex number which is in the form of a plus ib, that will have the separate real part as well as the imaginary part. So division is nothing but writing the two things and multiplying with the rationalizing factor of the denominator. Rationalizing would not be the perfect term here because we are having the imaginary numbers, but we would say the same thing because we have studied the same method of solving the sum. The next thing that we have to keep in mind is about the conjugate, modulus and the inverse of the complex numbers. For the given complex number z is equal to a plus ib, there is something called as a conjugate. The conjugate is denoted by z bar, and z bar is given as a minus ib for the complex number a plus ib. I'll say you the sign of the imaginary part has to be changed, otherwise the imaginary part has to be negated. Suppose I'm having a complex number 2 plus 3i. The conjugate of this complex number will be 2 minus 3i. And if suppose this complex number is written as z, the conjugate is represented as z bar. You're reading it as z bar, it is z conjugate. Z conjugate is equal to 2 minus 3i. Just keep in mind that the imaginary part, sign of the imaginary part has to be negated. Next, you are coming to the modulus. For the complex number z is equal to a plus ib, there is something called as a modulus. It is read as mod z is equal to root of a square plus b square will be the value of the modulus. The same complex number, if I take here, the mod z value will be equal to under the root of 2 square, that is 4, plus 3 square, that is 9. That will be root 13. Will be the modulus of the complex number z is equal to 2 plus 3i. Next, you are having the inverse. Inverse is also called as multiplicative inverse. Multiplicative inverse or inverse of the complex number z is denoted as z inverse. You are reading it as z inverse. Z inverse is also denoted by 1 by z, which will be equal to 1 by a plus ib. Once again, it is 1 by a plus ib. I told you we are not keeping the complex number where we don't have the a plus ib form. It is 1 by a plus ib. To simplify that, what I'll do is I'll multiply both numerator and denominator by the conjugate now I'll say, because a plus ib, the rationalizing factor, here I can say it's a conjugate. Conjugate will be a minus ib. A minus ib for both numerator as well as the denominator. As I multiply, here the numerator will be 1 into a minus ib, that is a minus ib itself. Denominator will be a plus ib into a minus ib. We know what is a plus b into a minus b. A plus b into a minus b is a square minus b square. The same way, a plus ib into a minus ib will be a square minus I square b square. Once again, the I square value. I square is minus 1. So you'll have a minus of minus b, that is a square plus b square. I can write the z inverse with the formula if I need. I can write it as z inverse is equal to a minus ib divided by a square plus b square. The three things, once again, conjugate is written as z bar. Modulus, we are having mod z is equal to under the root a square plus b square. Then the inverse or the multiplicative inverse of z, we are denoting it as z inverse given by 1 divided by a plus ib. That is about the first part of the lesson of complex number. The next part we are going for the complex number is the polar representation of a complex number. Here, in the polar representation of a complex number, the complex number we are assuming it is in the form of z is equal to x plus iy. It is similar to your value of a plus ib also, but x plus iy we are representing because this complex number x plus iy can be represented on a plane. As we use to represent a Cartesian coordinate system, a point in a Cartesian coordinate system, the same way z is equal to x plus iy. Here, I can consider the coordinate of x comma y and represent in a plane. And that plane is not called as a Cartesian plane. The plane that we represent the complex number is called as the Argand plane. In the Argand plane, I'll have two axes the horizontal x-axis, what we usually denote, we are calling it as the real axis, and the y-axis, what we usually call, is called as the imaginary axis. Representing the point in the first quadrant, I'll say the point is P and it is having a coordinate of x comma y. Now, in the real and the imaginary axis, if I have denoted a point of z is equal to x plus iy, taking the coordinates as x comma y and represented in a plane, in the argand plane, I can join that point to the origin. The distance from the origin to the point, we are calling it as r, representing it as r, and it is called as the modulus. The same thing, because the distance between an origin and the point is given by a formula, with the distance formula. If I consider the point is x comma y, the distance from the origin r will have the value of under the root x square plus y square. Here the r is also called as the modulus. The angle that this line OP is making with the x-axis, we are calling it as theta. Here r is called as the modulus and theta is called as the argument or the amplitude. Now, what is a polar form? The same complex number z is equal to x plus iy, representing here in the argand plane, is polar representation. Writing in the polar form, there is a form of a number where we can write in terms of r and theta. Complex number x plus iy can be represented in the form of r and theta. That is called as the polar form. The polar form is given by z is equal to r multiplied to cos theta plus I sin theta. Here, cos theta is equal to x by r and sin theta is equal to y by r. The values that we have to keep in mind here is the modulus, that is r. The value of r is x square plus under the root x square plus y square, and the theta. To find the theta values, I'll be having cos theta and sin theta. By comparison, I'll be getting the value of theta here. Once again, cos theta will be equal to x by r and sin theta will be equal to y by r here. I told you the complex number that is in the form of z is equal to x plus iy. Polar form of the complex number is given as z is equal to r into cos theta plus I in sin theta. Here, I told you what is the value of r. R is equal to under the root x square plus y square, and value of theta we are finding by the comparison of cos theta and sin theta. Now here, once again, I am telling you cos theta is equal to x by r and sin theta is equal to y by r. Now, in some cases, there is a particular thing that we do to get the value of theta. Here, theta will be in different quadrants. Some cases, theta will be in first quadrant, second, third, or fourth quadrant. How do I get the values when the theta is in different quadrants? I will tell you. If the value of theta, if the value of cos theta and sin theta both are positive, I can say x and y will be positive. If x and y are positive, theta is in the first quadrant. I'll draw you the quadrants that will have. In the first quadrant, the value is theta. The value of theta is found by the comparison of cos theta and sin theta. Coming to the second quadrant. In the second quadrant, I can say cos theta will be negative and sin theta will be positive. At the case when you are having either of the thing are negative, you do a rough work called as ignoring signs. You ignore the signs whatever cos theta and sin theta are having, and you are comprising the values of cos theta and sin theta as cos alpha and sin alpha without the signs. At that time, I'll get by the comparison, I'll get the value of alpha. That alpha value will determine the value of theta. In the second quadrant, I can say theta is equal to pi minus alpha. The same way, in the third quadrant also, you'll have both cos and y sign as negative. I'll be comparing the two things. To compare the two things, I'll do the ignoring signs. I'll get cos alpha and sin alpha. From that, I'll get the value of alpha. Then I'm finding the value of theta. In the third quadrant, it will be minus of pi minus alpha. In the fourth quadrant also, in the fourth quadrant, I'll have cos theta as positive and sin theta as negative. At that time, you'll ignore the signs once again. You're comparing cos alpha and sin alpha, you'll get the value of alpha. That direct value is given as negative alpha for your value of theta. The whole thing you have to keep in mind, this is to find the value of theta. In the first quadrant, you are getting the value directly. In the second quadrant, in the sense when cos is negative, you are finding cos alpha and sin alpha, then you are getting the value of alpha. Value of theta will be given by pi minus alpha. In the third quadrant, theta will be equal to minus of pi minus alpha. In the fourth quadrant, theta will be equal to minus alpha. Let us solve one simple sum about converting the complex number into polar form. The same way, I'm having a question here, convert minus root 3 plus I into polar form. Let me consider it as z. Z is equal to minus root 3 plus I. Now by comparison, I am having the value of x as minus root 3 and the value of y as 1. One more mistake that you students make is you'll consider the value of x as minus root 3, but the value of y you'll consider it as I. No, it is not I. It is the real part and the imaginary part that you have to consider. Imaginary part is 1, not I. So x and y values you know. First you are finding. Now the polar form is R. I'll write in the polar form. Z is equal to R into cos theta plus I sin theta. Here I need R as well as the values of theta to represent in the polar form. Finding the value of R. I told you we are having the formula to find the value of R. R is equal to under the root x square plus y square. That will be nothing but under the root. X square is minus root 3 whole square, that is 3, plus y square is 1 square, that is 4. Under the root of 3 plus 1 is root of 4. Root of 4 is plus or minus 2 basically. But the R value is the distance between the origin and the point. It is always positive. So you are considering the positive value, that is only 2. You got the value of R as 2. The next thing I have to find is the value of theta. Now to find the value of theta, I know what is cos theta and sin theta. Cos theta is equal to x by r. Sin theta is equal to y by r. Now I know the values of x, y and r. So cos theta will be equal to minus root 3 by 2. And sin theta will be equal to 1 by 2. I told you at some moment you'll have cos or sin. Either of the two things, one will be negative or both will be negative. Here cos is negative. We are very confident that when cos is negative, we are in the second quadrant. Now what I do, when either of the two things are negative, you are ignoring the signs. You are finding something called as cos alpha and sin alpha. Now cos alpha is by ignoring sign. Ignoring sign of cos theta, I'll write cos alpha will be just root 3 by 2. And sin theta, if I ignore sin also, I'm having the same positive value. Sin alpha will be equal to 1 by 2. Now by the comparison, cos alpha is equal to root 3 by 2 and sin alpha is equal to 1 by 2. You'll get the value of alpha. Usually by inverse trigonometry I would find, but being in the first year we are not aware of the inverse trigonometry. We are just finding by the comparisons here. Cos alpha and sin alpha. Now cos of what value is root 3 by 2? And sin of what value is 1 by 2. It will be the same value of alpha. I can say alpha is equal to 30 degrees. And 30 degrees can be represented as pi by 6 radians. Now I got the value of alpha as pi by 6. Now in which quadrant we are in? When x is negative and y is positive, or when cos theta is negative and sin theta is positive. We are evidently in the second quadrant. In the second quadrant, I told you what is the value of theta. In the second quadrant, theta is equal to pi minus alpha. Pi minus alpha, I know what is pi minus alpha is pi by 6. So it is pi minus pi by 6. The value will be 5 pi by 6. You got this as, now you got the value of r as well as theta. The two things that you require are r and theta. You are substituting that in the polar form. Therefore, the polar form will be, the polar form if I write, will be z is equal to r. R is 2 multiplied 2. Cos theta is 5 pi by 6. Z is equal to 2 into cos of theta, that is phi pi by 6 plus I sin theta, that is once again phi pi by 6. This is the polar form of the complex number. So once again I'll repeat you the methods. By the comparison of x and y values, you are getting it. Then finding the value of r, what is it? By the formula of root of x square plus y square. We have told you that cos theta is equal to x by r and sin theta is equal to y by r. We'll be knowing the values of x, r and y, substituting, getting the value of cos theta and sin theta. And if there is some negative values, we are going to find that alpha part, getting the alpha value, coming back, checking in which quadrant we are in. We are in the second quadrant now, so theta is equal to pi minus alpha, substituting the alpha value, getting the value of theta. Now both r and theta are substituted in the polar form. You are writing the polar form, that's it. This kind of question will be asked for 3 marks in your final exam. The weightage of this question, compulsory there will be a question given to you, convert a complex number into polar form. And the weightage is for 3 marks. It is a very easy sum, not that difficult of you. Just finding the value of theta, you have to use your brains. That completes the second part of your complex number, that is for converting a complex number into a polar form. Moving to the last part of the complex number, that is your quadratic equations. What is a quadratic equation? We have studied quadratic equation in our 10th standard. Quadratic equation, the equation which is of the form ax square plus bx plus c equal to 0 is a quadratic equation. There is a formula to solve the quadratic equation. The same formula is given. X is equal to minus b plus or minus under the root b square minus 4ac upon 2a. Now substituting the values here, what is the difference between the same question solving in 10th standard and now? Here you'll be having some negative roots. The same thing we had there, discriminant value, the value of b square minus 4ac will be less than 0. That means the roots will be imaginary. We are finding the imaginary roots. What might be the imaginary roots? I'll tell you, the b square minus 4ac value, if it is minus 7, you consider, then you'll have root of minus 7 in the formula. Root of minus 7, I can write it as root 7i. This is the only thing that you have to bother. You'll have a negative root. You are just expressing that negative root with an I. Just keep in mind. We'll solve one example about this and we'll wind up off. Solving. Root 2 x square minus x plus root 2 is equal to 0 is the given equation. I have to solve, means I have to get the value of x. Now by the formula method, x is equal to minus b plus or minus under the root b square minus 4ac divided by 2a. Now by the comparison, I know the value of a is root 2, value of b is minus 1 and value of c is again root 2. Substituting in the formula minus b, it will be minus of minus 1, that is 1, plus or minus under the root b square will be minus 1 whole square, that is 1, minus 4ac is 4 into root 2 into root 2 divided by 2a will be 2 root 2. Here 1 plus or minus under the root 1 minus 4 into root 2 is 4 into 2, that is 8 divided by 2 root 2. I'll have it as 1 plus or minus under the root minus 7 divided by 2 root 2. I told you we'll have a negative root. Look at that. We are having root of minus 7. That root of minus 7 can be expressed as 1 plus or minus root of minus 7 is expressed as the root 7i divided by 2 root 2. One more 3-mark question that we'll be having from the chapter is finding the roots of the quadratic equation. The roots will be imaginary roots. That's it. Just by using the formula of the quadratic equation, you're getting the root where you'll have some imaginary values. At last, coming to the summary of the lesson, we have studied the complex number. To define a complex number, once again, if I say a complex number, a number that can be written in the form of a plus ib, where a and b are real numbers and I is equal to root of minus 1. A is called as the real part, b is called as the imaginary part. Then coming to the powers of I told you I is equal to root of minus 1. The very important value that you have to keep in mind is I square is equal to minus 1 and the power of I power 4 will be equal to 1. Next, The conjugate of the complex number z bar is given by a minus ib. For the a plus ib, you'll have the conjugate as z bar is equal to a minus ib. Then the modulus is given by mod z is equal to root of a square plus b square. Inverse is given by z inverse is equal to 1 by z into 1 divided by a plus ib. First part. Next, I told you about the polar form. The question from polar form will be asked for 3 marks. There are few examples from your NCERT textbook. The same examples will be asked in your board exams. The same way, for the quadratic equation, finding the value will be also asked for 3 marks. The very 2 important questions from these days, converting into polar form as well as finding the root of the quadratic equation using the quadratic formula, which is an imaginary root. That completes the lesson, complex number. We have studied so many topics in our complex number. I have told you the marks that you have to concentrate. That is the 3 mark questions, 2 very important 3 mark questions from the lesson. That's from 2 mark questions from your first part also, and the 1 mark question from your first part also. The 3 mark question that you'll get, we will be getting from the 2 topics, that is your polar form as well as the quadratic equation. I'll be back with the next session with a different topic, and I'll reach you very soon. Thank you.